We will solve this numerical. So a block weighing 1000 Newton is rest over block B. So this is block A, which is rest, or this was block B, which weighs 2000 Newton. So this block B weighs 2000 Newton, whereas this block A weighs 1000 Newton. So if coefficient of friction, that is mu, is given, if mu between the block A and B is 0.25, so here this surface of contact, we can name it, let's say, surface 1. So mu 1, coefficient of friction between A and B is given 0.25, and between block B and floor, so between block B and this floor, so we can name it, let's say, contact surface 2. So it is mu 2 is given 1 by 3, 1 divided by 3. What should be the value of force P to move the block? So this is applied force P, which is acting rightward direction. So we have to determine the value of this force P. So to determine that value, so first we will draw the free body diagram, FBD, of that two blocks. So first let's say draw the FBD, free body diagram, of block B. So this is the free body diagram. So applied force P, so that will be the active force as well as its weight. So weight is given for block B, so it is 2000 Newton. Then reactive forces, so that will be this contact surface 2, so here normal reaction, let's denote it by N2. Here surface 1, so normal reaction N1. Now when this block will move towards right, when this block B will move towards right, so friction between surface this A and B and between surface B and floor, that both the friction will oppose this motion of block B towards rightward. So this is the direction of motion. So frictional force will be opposite to this direction, so that will be towards left. So that will be F1, and again here towards left, so that will be F2. Okay, so it is like this, two surfaces are there, and this pen, it is that block B. So again we can write F is equal to mu into N. So here F2 will be 1 by 3 into N2, whereas this F1, so mu between 1 is 0.25, so it is 0.25 into N1. So that will be the free body diagram of block B. And again we cannot solve here this FBD because the number of unknowns are P, N1, N2. So three number of unknowns are there. Since we have relation between F1 and N1, so if we know N1, we can calculate F1. If we know N2, we can calculate N2. So here only two unknowns and here P. So three unknowns are there. So again we will draw the free body diagram of block E. This FBD of block E. So again here, if you see the diagram, this block E is attached to this wall by using this is a string. So there will be tension in that string, so we remove the support so that we will cut this string. So when we cut this string, so we will show the tension in that string T. This is block E. Again its weight acting downward direction, weight is given 1000 Newton. Then reaction, now notice this point, at point 1 there will be equal and opposite reaction. So when we draw the FBD of B, we show N1 downward, so here N1 will be upward. Similarly here we will show F1 towards left, so in this FBD of block E, this F1 will be towards right, again 0.25 N1. So again that FBD of block E, so methodology of solving this numerical will be from the free body diagram of block A. Using condition of equilibrium, we can determine N1 and F1. So here N1 and F1, that N1 F1 determine using FBD of block A, we can use that here in the free body diagram of block B, and we can determine N2, F2 and force P. So to do that, so again here using conditions of equilibrium. So using condition of equilibrium, so using first condition, summation fx is equal to 0, so we can write minus t plus f1 is equal to 0, or we can write t is equal to f1. So for f1 we can write 0.25 n1, so 0.25 n1. Then using second condition, so algebraic sum of vertical component of forces is equal to 0, so that will gives us n1 acting upward, therefore positive, minus 1000 Newton is equal to 0, so we get value of n1 as 1000 Newton. Then using that value we will get value of f1, so that will be 0.25 into 1000, so that will be 250 Newton. So putting this value in this equation, so that we can get value of tension will be equal to 250 Newton. Then again, so using this value of n1 and f1 in the free body diagram of this block, so here n1 will be equal to 1000 Newton and value of f1, so that will be 250 Newton. So again using that conditions of equilibrium here, so again using conditions of equilibrium, so summation fx is equal to 0, so that will be p minus f1 minus f2 is equal to 0, so we can write p is equal to, for f1 we can write directly its values, that will be 250, plus for f2 we can write 1 by 3 and 2, so equation number again let's say 1. So using that conditions of equilibrium we will solve that numerical. Again second condition, using the summation fy is equal to 0, algebraic sum of vertical component of forces is equal to 0, so that will gives us n2 minus 2000 minus n1 is equal to 0, so that will give n2 is equal to 2000 plus value of n1 it is 1000. We get value of n2 as 3000 Newton, and putting that value in equation number 1 we will get value of P, so that will be 250 plus 1 by 3 multiplied by 3000, so that will be 1000, so here 1250, so that will be value, that will be our answer, Newton. So when we applied force of 1250 Newton at this point P, or this value of force P, then this block B will start moving towards right. So in this numerical, the important point to be noted is the friction between A and B and the FBD of block B. So at point A and B, when this block B is going to move towards right direction, so both its friction, so between block AB surface 1 and between block B and the floor surface 2, so that will be oppose the motion, so that will be towards left direction. And then so FD of A, so though block A is not going to move, though block A, because here string is there, the block is attached to the wall by this string, so though block 8 is not going to move, there will be the friction force at this surface 1. So when this block will move towards the right, so its friction F1 towards left, so when we do the FD of E, that friction will be towards right. So this important point is to be noted. Okay.